that represents what?
Water.
The ocean. If you can't see because I'm blocking you, you can move to others. Okay, anybody if you need to. Okay. So we have here a tub of water that represents the ocean. Okay, and we have a heat source that is underneath here, and that's going to be representing warmth. Okay. I do need somebody run to the back freezer and grab a tray of ice cubes. Okay. This here is plain, regular tap water. It's the same temperature as the water that's in here. So, yesterday when you did your lab, you kind of already did this. So I'm going to inject some red water in over this heat source. What's going to happen to it?
It's going to rise.
It's going to what?
Rise.
Why is it going to rise?
The heat.
Because of the heat. The heat is going to warm that red water up, and it's going to rise to the top. So that red water is going to represent what kind of current?
Warm.
A warm what kind of current?
Water.
A warm
Surface
current. Thank you. Okay, so I'll leave that there. I'll put one more in. Leave that there for a little bit. And look at that. You can already tell that it's rising to the top. And then it's moving over towards the poles. What am I going to do to represent the poles?
Ice cube.
Blue ice cubes. What is going to happen when I put this blue ice cube in here?
It's going to float.
Well, the ice cube will sink, but what's going to happen to the water off of it?
It's going to turn blue.
It's going to sink.
It's going to sink. Why is it going to sink? Look at that. Look at that water. Immediately sinking down to the bottom. Why is it sinking? Because it's so much colder, therefore it's way more dense than the surrounding water. Check that out. Look how fast that sinks. Okay? And look, that red water is becoming a surface current and it's rising. That deep water is becoming that blue water is becoming a deep current, cold deep current, and it's sinking. And look at the convection current it's creating. When this red water gets over to this blue pole, to the poles, what's going to happen to that red water? It's going to start sinking right there when it gets to the polar ice caps. And then similarly, when that polar water, when it gets to the equator over here, what's going to start happening to it? What's already happening to it? It's going to rise. That's called what? Convection. That's the global conveyor belt that you guys see on the screen.
What's the green stuff for?
I'm getting to the green stuff. Okay? Look at that. Blue water, it was cold, but it got to the equator, so now it's rising and becoming a surface current. That red water was warm, but now when it's getting, look at it, it's starting to sink over here. And you're getting this convection current happening. I'll even put a little more red water in. And I'm going to put it right over here by that blue. And look, it's rising up over here and sinking down over there. Now, what do you think the green water is?
Green water.
Salt water. Okay? Salt water is more what? Dense. So therefore, what's going to happen when I put this?
It's going to sink.
Check that out. Going straight to the bottom. And I'm not injecting it to the bottom. As you notice, I'm putting it on top of the water because I don't want you to be like, well, she's putting it down there. Nope. That water is going down there all on its own because it's heavier, saltier, and so it's going to form, it's going to combine with that blue, and it's going to sink. And as you can see, you've got this striation going on where the red's at the top and the blue's at the bottom. That make sense?
Yep.
Make sense? So the key to this is that convection, this is how water moves in the world. It moves because temperatures are different. Now, why are the temperatures different? The main key fact above everything else. Why are the temperatures even different in the first place?
Because the sun hits unevenly.
Because the sun hits the earth unequally. More at the equators and less at the poles. Awesome.